Sorry. Okay, so I did my project on AI, and I chose AI because I was very interested from the beginning, and I started work with transistors. Now, transistors are basic on and off switches that are used in electrical circuits and to make technology today. And I needed some way to connect that to biology, and I found out artificial intelligence, something else I'm also interested in, mimics natural intelligence, which is the intelligence of organisms that are biological. So that's why I chose artificial intelligence. So what is AI? So this is a definition from Merriam-Webster, and it says AI is a branch of computer science dealing with the simulation of intelligent behavior in computers, and AI is going to find John Connor and take over the world.
You may not, people may not know that reference.
Terminator. Arnold Schwarzenegger. Okay, so where can you find AI? Now, AI, we may not realize it, but it's everywhere around us, even though it might not say it's powered by AI. So a lot of ride-sharing apps, for instance, Uber and Lyft, to find your rides and to calculate where the drivers should actually go, they use different types of AI, multiple in fact. And then if you've ever used like Google Maps and you want to go somewhere, the traffic predictions are actually based off of routes that have been taken by other Android users, and it finds where traffic is on a day-to-day basis, then calculates a route for you. Commercial airline flights, like low-budget flights that usually aren't that important to an airline, are calculated by artificial intelligence because they don't see manpower being used there, and one person can't go over thousands of flights of data. Email spam filters. If you have a spam filter on your email, that's usually because of an AI is finding which email has been sent to millions or thousands of other users and why this is important to you. Plagiarism detectors. A lot of schools have these. A lot of teachers use them. It basically scans the whole paper, and no one really knows how, because it's not shared, how they use it. It scans if any of your work has been copied off of anywhere, and if that work isn't cited or any quotation marks. Then social networks. If you're wondering how your recommended section works or any of that, that's actually from AI looking through your search history, what tags you use, and finding what you might be interested in. So what is AI based off of? So artificial intelligence is based off something called natural intelligence. Now, even like the most simple creatures have a lot of power in natural intelligence. Like a cockroach is smarter than our most powerful AI at doing most tasks. The most common artificial intelligences, AIs, are based off of the human brain and our neurons and our neural network. So here's a few interesting facts about the brain you might want to know. So there are 86 billion brain cells, and they all form a huge network that pretty much is your brain. A neuron, a single cell, can transmit 1,000 nerve impulses a second. So it sends like electricity to other nerves 1,000 times in 1 second. Your brain, since it has so much electricity, has enough to power a small light bulb, which is 10 to 25 watts of electricity. And the human brain is 30 times faster than the world's fastest supercomputer K at processing brain data, which is basically images, videos, sound, all of that, faster than the world's fastest supercomputer. This is a neuron, if you're wondering. These are brain cells, and I don't have my cursor. Okay, I don't. Oh, yeah, I do, actually. So these synapses, they actually form a whole network where you have multiple different neurons connecting to one neuron, and then it makes this whole network. And this is how thoughts and feelings are kind of transmitted. They go through neurons by firing through multiple different neurons and finding a path to your brain. Okay, so here are a few common misconceptions about AI in general. Now, people think that automation and AI are going to take all the jobs on the planet, which just simply isn't true, because who's going to make the AI? Some jobs just can't be taken by AI, like physicians. You can't trust like everything to be done by a machine. Supercomputers powered by AI will do everything we do, but a lot better. And there are certain things that like computers even now can't process. Our brains can process images, videos, and sound faster than any computer can. And our brains have enough data, or can store enough storage in our brain if it were to be translated into megabytes, and gigabytes is equivalent to like the whole internet 3 times is how much space we assume that our brains have. And another common misconception is that like factories will be taking the only jobs taken over by AI and automation, but that also isn't true. Like a lot of jobs in corporate setting, like many desk jobs, accounting for one, is a dying field just because of automation and AI. So how does AI work? So there's a few different types of AI, and each works in a different manner and a different way. So a very popular way is through a system of logic gates, this is the one that copies the human brain as it uses a neural network. And this is one of the more popular types because it's very simple to create and simple to use. And then there's other more complex types of AI using sets of algorithms and machine learning, which in the AI itself is learning about what's happening around it. And they use these massive, massive data sets that are usually bought. So this is a graph I call the AI pyramid that I made. It basically shows like how AI is built off of and what different components are used to make AI. Starting with artificial intelligence at the top, and then artificial intelligence made of neural networks made out of the logic gates, and logic gates made out of diodes and transistors. This is another graph I made just showing how there's like big broad fields and how they slowly narrow down. So transistors being the largest, and logic gates being even smaller field, and neural networks even smaller field than AI for the smallest. So I have a whole other section just dedicated to neural networks. This is highlighted on the pyramid. So what does a neural network do? A neural network is basically a set of inputs given by a user usually that go through can be a few to like millions of different outputs, different choices to get a single output. And this could be used for anything from like finding a video that you're looking for in a search engine to finding the correct path from rideshare app. Now they use like very large data sets. There's like millions and billions of images and pictures and videos or data routes are collected by Android users usually, and they recognize like the patterns in the data to find the right choices. Now, in the beginning stages of an AI, what usually happens is the AI is given a few choices and it is asked how to find the right output. When it finds something wrong, it'll tell the AI, or the user tell the AI, this is wrong, and they keep going through this process until the AI has gone through enough data to find out which options are right and which options are incorrect. And they stimulate brain selectivity by using logic gates to answer a yes or a no, and these yes or no's can be used to simulate the neurons firing different pulses. So what are the types of neural networks? Just quickly, I don't have my note cards. I don't have like the descriptions of these. There's one that I'm like copying here called the feed-forward network. It's a more simple AI. It's easy to explain, as others can. Others are based off of other AIs and other networks that aren't really related to my project. There's the long-term storage memory network. There's an RNN network, and then there's a CNN network. So what kinds of data do they use? This is a really interesting field, as some can use multiple data and some can only use one or two. So sound is one very popular one for voice recognition and things like Siri and Cortana. Then there's text, which is like your Google search or search engine. There's a time series, which is like how long you're viewing something, how long you're watching something. And there's images, which are just basic images, and then video, which is a combination of images, sound, and time series. So what makes up a neural network? Now this is a graph I borrowed from University of Wisconsin, I think. So this shows the input layer. This is a very simple one just to explain the whole concept. This is the input layer. These are the connections made between all the other hidden options and choices that the neural network makes itself. And this is the output layer, which usually gives one to a few outputs for the user to see. So these different layers are very important, as some massive AI will have hundreds of layers with millions of connections, and the input and output layer are the very small layers that the user will see. And each layer, like each one of these connections, is actually a logic gate. So now logic gates, which would be the next thing, which what neural networks are made out of. So right under neural networks. And what is a logic gate? So logic gate, by definition, is an elementary building block of digital circuits. So basically, it is something that isn't physical, but is used in programming. And it basically takes two outputs and gives one output. So they're usually binary outputs since they use transistors. So that'd be 0 and 1, and returns as 0 and 1. So there's quite a few types of logic gates, but these are a few simple ones that are used to create other types of logic gates. There's an AND gate, an OR gate, a NAND gate, and a NOT gate. And they all give different outputs based on the two different types of inputs they're receiving. So where are they used? They're used everywhere, mostly digital projects. There's computer memory, microprocessors, digital electronics, and like most digital projects, just about every digital project has a logic gate of some sort if it has any code or programming. So what are logic gates made of? They're made of transistors and diodes. So transistors are basic on-off switches, and diodes are essentially half of a transistor. So this is my next unit on transistors. So they're the very base of all digital electronics and physical electronics. So why are transistors so important? So they make up all electronic technology, which is why they're so important, because they're found everywhere in our lives. They have advanced almost every field that now uses electronics with the capabilities to create programs and small computers. And they help create the internet. So memes, pretty important. And they made computers smaller and cheaper as they've slowly gone so small that they're smaller than the width of a hair. So what is a transistor? It's a simple on and off switch. It's made of doped silicone. Now silicone is one of the most common materials on the planet Earth. Like 1/4 of the Earth's crust is made of silicone, and it's a diode's cooler brother. So a semiconductor. This is like the material that makes most electronics. So silicone is the one used as it's so abundant and it's one of the best conductors to make the silicone plates. So silicone is doped, which means there's like special molecules that are kind of been injected into the silicone to create 3 different regions, and these regions create a semiconductor, which means that silicone can be turned both on and off by sending electricity to different parts of that piece of silicone. And ICs are integrated circuits, and diodes and transistors are like the 3 main components made of like almost completely silicone. So what do these transistors code for, since they pretty much code everything? So when a transistor is on and when it's off, they code binary, such as simple zeros and ones that you might see like everywhere. So how big is a transistor? This is the really interesting portion of it. So it can range from a few inches inside to like 7 nanometers. Now there are 75,000 nanometers in the width of a human hair. It just goes to show how small they are, and there are billions of them in like your cell phone, and even more in your computers. I don't know if you can see this. Oh, shucks. Well, it shows a comparison of how 1 nanometer is the width of DNA. So a 7 nanometer transistor is 7 times the width of DNA. So in conclusion, what you might want to take away from the presentation is that artificial intelligence is a system of neural networks, the most common type. A neural network is actually a system of logic gates. A logic gate is a group of transistors and diodes, and the transistors are basic on and off switches. Then, huzzah.